This is a 1D resistivity survey, and this is the general layout. So you can see that we have these two Barker cables that come together and join at the middle. We've put an electrode through this central ring, and then after that you can see that the spacing increases with each distance. So the first two will be 25 centimeters, then the next one will be 50 centimeters, a meter, 2 meters, and so on. You can see that at each breakout we've connected the breakout to the electrodes using these crocodile clips and ensured that we have a good connection to the ground. Then the Barker cables, which have the electrodes on them, are plugged into this control box. We connect the central electrode using this crocodile clip. And then we join the control box to our thermometer using these wires. You can see that it's clearly marked which ones are current and potential. So this connects into the potential, and this is the second potential, and this is the current, and this is the second current. So they just slide into the control box. We also need to connect the thermometer up to the battery and turn it on. We can check what the battery life is relatively easy using this selection here. So let's have a look at the thermometer, and what we can see is that you can choose to measure either the voltage or the resistivity. We're choosing to measure the resistivity because we know how much current we're putting into the ground, and that's what will allow us to get our 1D survey going vertically downwards. We also can change the number of cycles, which is the number of readings that we're taking, so we can take an average later in the classroom. To take a reading, you just press this big red button. So it will beep 4 times to give us readings, and then it will give us the average. This is the control box, which allows us to choose what spacing we're interested in and also what type of survey that we want to do. So with setting number 1, we are on the shortest spacing. So we are using the 4 electrodes that are 25 centimeters apart. This allows us to do a Venn alpha array with our 2 potential electrodes and our 2 current electrodes. To then increase the spacing, we would no longer use the innermost electrodes, and instead we would use the central electrode and those at 50 centimeters. This can go all the way along up to a greater and greater spacing, which allows us to look deeper and deeper into the subsurface in that 1D survey. We also have these settings here. So we have Venn alpha, Schlumberger, dipole 1, dipole 2, and Venn beta surveys. These are just different arrangements of using current and potential electrodes to get slightly different understanding of the subsurface. Just note down exactly what survey, exactly what setting you're using in your notebook, measure the readings, write down the averages that come up on the screen, and always keep one survey consistent when you're doing your analysis.